So to solve this question, first thing you need to do that you have to find out the performance grade assigned for Hamilton. So that will need you to go through the protocol or the protocol is defined in the Hamilton. So for the super pair mix design in Hamilton, which would be the you can see that it's under the zone 3. So the performance grade, the default performance grade is a PG 58 minus 28. So this is the default value. And we were actually trying to construct a new freeway. So we're going to use all the new materials, the new hot mix asphalt. And with that, so we will have the base scenario, the base performance grade. But we also need to think about the traffic conditions. In Hamilton, for that freeway, we are considering the a road with the volume higher than with the traffic of 45 million. So this will clearly falls under the category E, and this would be the freeways. It also verifies our categorization. It's category E, and then for category E, we need to do some adjustment or some increase about the performance grade. For the urban freeways, we usually need to increase from the standard about 2 grades, which means that we need to increase the maximum temperature for about 2 times 6 degrees. That will be 12 degrees. You don't need to do any additional adjustment about that. So with that, if we go to see the questions, the default one is PG 58 minus 28. And you need to get a 2 grade improvement. So you need to add 12 degree for the maximum. This will give you the final answer as PG 70 degree minus 28. So that will be the answer for the first question. So you have to combine all this information together to find out the right performance grade. And for the second question, we are talking about the performance mix design from the SGC test, and we have obtained all the informations, the binder contents, the GMM at the initial, and we also can find out the air void, the VMA and VFA. We want to identify the estimated VMA. So for that one, if you can recall the equation that we specified in, I guess, in Note 15. I'm just trying to find out the slides for you. So we have an equation to calculate the VMA, the estimated VMA based on the air void and the value you observed from the SGC test. So VMAE is VMAI plus C times 4 minus VA. So in this case, we want to find out VMA, the estimated value, which will equal to VMA, the initial value, plus C times, I guess it's 4 minus VA. 4 minus VA. Here, VMAI is the one from the experiment. What you get is 14.1. And you have VA equal to, that will be the air void, that will be 5.3. And the next thing you need to identify is the constant value for the C. From this notes, we define the C as 0.2 if the air void is higher than 4%. So with that, C is 0.2. So we can then calculate the estimated VMA as 14.1 plus 0.2 times 4 minus 5.3, which will give you the result as 13.8. That will be the answer here. So this is the way for you to find out the estimated VMA. Of course, you can using this information to find out the estimated as for the binder contents. Okay, so that will be the answer of the 2 questions in the last lecture. Do you have any questions or comments about this one? If no, then I will go to the introduction about the new lecture, the estimations about the traffic loadings and the volumes, which will be one of the key components for us to design the pavement. So let me try to bring out the notes. So actually, we know that the pavement is actually designed to support the traffic on the road, and the amount of the vehicles moving on the road and the loadings of the vehicles is very critical for us to identify the performance of the pavement structure and what's the cycle of the pavement, and also what's the frequency for us to do the maintenance. Let me try, there'll be something. Let me remove the timing. The estimation of the traffic loading and the volume is actually highly related to the configurations of the vehicles, the configuration of the gears of the vehicles, and also the type of the vehicles. Generally, the loading from the truck is much higher than the passenger cars. So in the pavement design, usually we will only consider the impact or the traffic load from the trucks or some large vehicles on the roads. And then for the trucks, the structures of the tires will usually be different from the passenger cars. For the passenger cars, usually will only have 2 wheels, 4 tires. But for the trucks, we have different combinations of the tires and wheels. So here would be 3 typical type of the axis applied or wheels applied for the trucks. We have the single axle, single tire, where we only have 2 tires on each side with only 1 axle. And you also have the tandem axle dual tire. So here you will actually find out the 8 tires, 4 on each side, but you will have 2 axles to support these 8 tires. You will also have another combination that will be the trident axial dual tires. So for each side, you will have 6 tires, but you will have 3 axles. So those would be 3 common type of the axles applied for the trucks. In the pavement design, we will actually have some definitions about the axle and the wheel combinations. We have the single axle dual tire combination, single axle with single tire, which will look like this one. We have the tandem axle with dual tire. We have the trident axle with a dual tire. And for all the other type of the combinations, we just categorize them as some rare case as the other type of the combinations. So this is the axle and wheel types that we're gonna apply for the estimation of the traffic loadings. And there will be also some factors which will affect the estimation of the traffic loading. Usually, for the direct factors, we have to consider the gear configurations of the tires, the spacing between the tires, the load applied to each tire, and also the tire pressure that will be applied. Usually, the tire pressure is directly related to the loading pressure. And also, there will be some indirect factors like the pavement design, the pavement design, the structures of the pavement will also have some impact about the stress or the deformation of the load applied to the pavement structure. The vehicle types, this is obvious. The truck, large truck, small truck, the passenger cars will have very significant different impact about the stress and deformation. The speed of the vehicles will have some impact. The volume of the vehicles, the frequency for the vehicles to passing one fixed locations, the frequency of each vehicle type, the high volumes of the passenger cars and high volumes of the trucks will have very different impact to the performance of the pavement. The lateral wonder of the vehicles, this is usually what related to the shear strength of the pavement structure, and it's very important for us to design the road with certain curvatures. So those would be some factors which will affect our estimations about the stress and deformation from the vehicles to the pavement structure. So usually for the pavement design, we need to find out some standard variables to estimate the traffic loadings. Generally, for this kind of estimation, we can consider three different methods. One is based on the fixed traffic, where the traffic condition on that road is pretty consistent. Like there will be 100 vehicles moving on the road, and maybe 20 of them will be the trucks, and they will passing the road with the constant rate, constant frequencies. If the traffic condition is constant or the traffic condition is fixed, then we can use the equivalent single wheel load to estimate the or to evaluate the traffic loading. With this kind of condition, as we consider traffic is constant, so we can ignore the repetition or ignore the volumes of the traffic. So this is the first type. And the second type is called the fixed vehicle, which is the most common method. It comes from some practice or from some field experiments. With this kind of method, we will consider a number of the repetitions of the standard vehicles or the standard axle load. Generally, we define the value as 18 kilopounds or 80 kilonewton. This kind of standard load is called ESAL, which we referred a lot in the previous lectures. So here ESAL stands for the equivalent single axle load, and in the next lecture we will focus on the introduction about how to calculate the ESAL for different type of the vehicles for different traffic volumes. And there's another method which is called the variable traffic and the vehicle method. So they will divide the load into different groups. This one is developed by Portland Cement Association. It's a more advanced, modern method, but they haven't been adopting any California roads, not any Canadian roads. So we will not include this one in this class. In this class, we will focus on the first two methods, the fixed traffic method and fixed vehicle method. So first, for the fixed traffic method, as we mentioned, we're going to use the equivalent single wheel load to estimate the traffic load. And in this kind of method, we will ignore the repetitions of the vehicles. We will only consider the traffic, or we consider the load from the truck directly, and don't consider how many vehicles will pass in the road during unit time. For the estimation, we need to consider different type of the equivalencies. We can consider equivalency with respect to the stress, strain, or the deflections, or the damage parameters. Generally, there will be four type of the criteria we could be applied to identify the equivalency: the vertical strain at the top of the subgrade, the tensile strain at the bottom of the asphalt concrete, the equivalent maximum vertical stress at the predefined depths, or the equal maximum vertical deflection at certain depths. So those would be the 4 common criteria we're going to use for the estimation of the ESWL. And with different criteria, the formulas for the estimation will be different. Let's go through them one by one. First, let's consider the equal vertical stress criteria. Usually if we consider the distributions of the stress between the tire, the load will be changing with respect to the pavement thickness. Basically, with a higher thickness, the stress will be smaller, and because it will be distributed to larger regions. And the figure here can show you how the load applied to the dual tire. So we have the tire 1 and tire 2 will be distributed under different thickness of the pavement. In this figure, you can consider SD will be the distance from the center of one tire to the center of the next tire, from tire 1 to tire 2. And D will represent the spacing between these two tires. So it's from the right end of the tire 1 to the left end of the tire 2. Of course, SD here is larger than D. And the value PD is the load applied to each tire. So in this case, the total load will be 2 times PD. So which will be the we define here PD. We define PD as the load applied to each tire under this dual tire system. And if we go to check the distributions of the stress under the different depths of the pavement structure, you can find that if the thickness is less than half D, then the stress from the two tires will not overlap with each other. So there's no overlap. But if the thickness is higher than 2 times SD, then we can find out that the stress from these two tires, from tire 1 and tire 2, will completely overlap with each other. Of course, this is just some approximation, but we can get this kind of result as the end with the depth higher than 2 SD, their impact will overlap, and we could consider as one single tire, the stress generated by one single tire with the load of 2 PD. So in this case, the equivalent single axle load in this region, equivalent single wheel load will be 2 PD because they are not overlap with each other. But when the thickness is higher than 2 SD, then the equivalent single wheel load will be 2 times PD. So they will overlap with each other. The things like for the thickness less than half D and for thickness higher than 2 SD, it's quite simple, but we still need to determine what's the ESWL for the thickness between half D and 2 times SD. So for this kind of estimation, we can use some empirical or some practical data. Generally, we can use a linear relationship to find out the relationship between ESWL and the depth, which would be the thickness from the surface of the pavement structure. So if the thickness is less, or the depth is less than half D, then the ESWL is 1 PD. If it's higher than 2 SD, it's 2 PD. So this is what we conclude from the previous page. And for those in between, we're gonna use the line, a linear relationship to describe the relationship between ESW and the depth. And here you have to remember that for both axes, the horizontal axis and vertical axis, they are under the log scale. So it's not the linear value. So with that, we can actually find out the equivalent single axial or single wheel load with the thickness between half D and 2SD with this linear relationship. So they are all under the log scale. And in this equation, PD is the load on one of the dual tire, and Z is the thickness of the thickness under the pavement that we want to estimate. D is the clearance between the dual tire, and SD is the center spacing between the dual tire. So with that, we can find out the ESAL at any depth of the or any thickness under the pavement structure. So first of all, let's have an example to see how we can using this relationship to estimate the ESWL. We'll consider a set of the dual tire with a total load 2 PD of 9,000 pounds, and the contact radius A is set as 4.5 inch, and the center to center tile spacing SD is 13.5 inch. And we want to determine the ESWL at the thickness of 13.5 inches. So here we need to use all these assumptions and the equation we defined in the previous page to estimate the ESWL. So in this example, of course, we want to record a linear relationship. First of all, we have to list all the assumptions from this example. We know the traffic load 2 PD is 9,000 pounds, which means that 1 PD is 4,500 pounds. And we also know that SD is 13.5 inches. And we know the radius of the contact area is 4.5 inch. So with that, I just have asking a quick question. What's the distance? What's the spacing between these two tiles? If we are provided with this information, what's the spacing between these two tiles? Were you able to find out the spacing based on this information? Does anyone have an idea about how to calculate the spacing? You know the center to center distance of the two tiles. You know the radius of the tiles. What's the spacing between these two tiles? Any idea about it? Okay, maybe it's more straightforward if I draw these two tiles. So we have the tile 1, we have the tile 2, and they all falls on the pavement, and the center to center distance. So this is center to center distance as 13.5 inches, and the radius is actually determined by the width of the tire. So the radius of usually the width of the tire will be 2 times of the radius, which will be the diameter of the contact area. Well, in that case, we can see that the distance from the center to the edge of the tire would be A, that would be 4.9 or 4.5 inches, and similarly apply to this tire. Usually these two tires will have the same size. It's also 4.5. So with that, the distance between or the spacing between these two tires will be SD minus 2 times A. So in that case, we get the result as 4.5 inches. So this is the spacing between the two tires. And we also know that we want to find out the ESWL at the thickness of 13.5 inches. And with that, we can then recall the equation, the log of ESWL equal to the log of PD plus the constant 3.1 or 3.01 times log 2 times z divided by d divided by log 4 times sd divided by d. And you know all the informations. You know PD equal to 4,500 and Z is 13.5, D is 4.5, and SD is 13.5, and D is also 4.5. And with that, you can find out the log ESWL as 3.87, and then you can get the value of ESWL as 7,410 pounds. So this is the way for us to use the equal vertical stress criterion to calculate the ESWL at any thickness of the pavement structure. That's the first one. We can also calculate the ESWL with another method, which is called the Boussinesq theory, where the ratio between the single axle load ESWL and which will be PS, and the load applied to one of the dual tire is in the ratio between the sigma z and QD divided by sigma z and QS. Here sigma z is the vertical stress applied at the depth of the applied depth of z, and the QS is the contact pressure under the single wheel, and QD is the contact pressure under the dual wheel. Just a moment. I think I run out of the battery for my pen. I'm just gonna use my writing pad to do that. Okay. So this is the this is the way for us to calculate the ESWL with the Boussinesq theory, and usually we need to find out the ratio sigma z over QD and sigma z over QS under 3 points. The point 1 is actually directly behind the center of one tire, and 2 is actually at the edges of the tire, and 3 will actually be under the center of the two tires. And you have to find out use the maximum value of these 3 points to find out the or actually to estimate the value of the sigma z over QD and sigma z over QS, and using that value to calculate the single wheel load. I'm going to using one example to tell you how we can using the Boussinesq theory to estimate the ESWL. So first of all, for the I guess I'm run out of my battery. Just a moment. Let me try to find out an additional document so that I can try to show you how to what's the answer for that. Just a moment. Let me try to bring out another file. So here I have the file shared with you on Avenue to Learn, and I'm gonna go through with that. Just a moment. It takes some time for me to download it. Okay. Okay. Let me try to see whether it's able to see it. Okay. So I guess this is the one with the all the informations have already written. So with that, you can actually see the just a moment. Okay. I'm sorry, just give me a moment. Let me try to fix this one. So I'll just go through these notes and try to make sure that we I go through the right steps. So basically, if we are trying to using the Boolean-X theory to estimate the ESWL in the first example, in this example, we need to measure the stress, the vertical stress at these 3 points with respect to the contact pressure at the single and the dual wheels. So this value could be measured from the experiment. And at the left wheel, you can find out the ratio between the vertical stress and the contact pressure, QS, at a single wheel as 0.143 at point 1, 0.126 at point 2, and 0.088 at point 3. You can also find out the value from the right wheel, which is 0.030 at point 1, 0.053 at point 2, and 0.088 at point 3. As these two wheels, as the right wheel is a little bit far away to the left to those 3 points, this wheel is far away to these 3 points. So point 1 will have the smallest value, and point 3 will have the highest value. And the value at point 3 and at point 3 for these two wheels will be the same. Then you can find out the value for dual wheels, which will be the sum of these two values. For example, at point 1, the sigma z over qd will be 1.43 plus 0.03. So you add them together. At the first point, you have the value of 0.173, and you have the value for 0.2 and 0.3. And now you need to determine what's the value you have to use for the Boolean-X theory. For the dual tile, you need to find out the maximum value of all these 3 points. In this case, you find out the value is 0.179, which is the highest value. And for the single wheel, you also need to find out the maximum value of these 3 points, which will give you the highest value as 0.143. So now you have these two values. Then we can recall this equation to calculate the value of ESWL. So here, ESWL is just the PS, and the PS will equal to sigma z divided by QD divided by sigma z divided by QS times PD. From our previous description, we know that sigma z over QD is 0.179, which is the maximum value in this column, and sigma z over QS is 0.143, which would be the maximum value in this column. And PD is the one that we estimated from the previous example, that is 4,500 pounds. And with that, you can estimate the ESWL as 5,630 pounds. And this value is actually much smaller than the one that we calculated previously, 4,710 pounds. It means that there will be some significant difference between the Bose-Nash theory and the one we use the linear relationship. And so that's the second method we can apply it to for the equal vertical stress criterion. The third one we're going to use is called the Fosteralvins Message. And in this method, we will consider the vertical deflection at a depth equal to the thickness of the pavement obtained from the Bose-Nash solution. So the in this method, it defines the deflection at a single wheel and dual wheel. So they have the equation single wheel omega s equal to qs times a divided by e times fs. And here a is the radius of the contact pressure, e is the elasticity modulus, and fs is the deflection factor for the single wheel. And similarly, it defines an equation for the dual wheel. In the dual wheel, you have WD equal to QD times A divided by E times FD. So here QD is the load from the dual tire, and the FD is the deflection factor for the dual wheels. And in this method, we have to they're going to assume that the deflection from the single wheel will be the same to the deflection to the dual wheel. So you have the value of omega s equal to omega d. If you put these two equations together, you can find out a simplification about the relationship between QS and QD. So basically, they apply the same radius of the contact area. Both of them are A. They have the same modulus of elasticity, which comes from the pavement structure. So with that, you can find out the QS times FS will equal to QD times FD. And if you want to find out some further relationship, you can convert QS and QD to their load, to PS and PD. As the QS is the contact pressure, the contact pressure will usually equal to the load divided by the contact area. Or we say that load equal to the contact pressure times the area. And usually the contact area is in a circle. So once you are provided with the radius of the circle or the contact area, say that is A, then we can know the area is pi times A square. So with that, you can have P equal to Q times pi times A square. And this will be applied for both single wheel and dual wheel. So you have PS equal to QS times pi times A square, and PD equal to QD times pi times A square. So with that, you can simplify this equation to identify the value of ESWL, which would be PS. That one could be further simplified as FD divided by FS times PD. So here FD is the deflection factor of the dual tire, FS is the deflection factor of the single tire, and PD is the load from the from each tire of the dual tire. And here I'm going to give you another example about how to calculate the how to use the Foster and Alvins method for the estimation of the ESWL. Usually for this method, you will be provided with the deflection factor under the dual wheel and the single wheel, and also we have to identify the deflection factor under the 3 points that we specified. One directly behind the center of the one tile, one is at the edge, the other one is at the center of the two tiles. So that will be point 1, 2, and 3. And similarly, you can find out the deflection factor for the single tile of the left wheel and right wheel. And for the deflection factor of the dual tile, you need to add the deflection factor of these two tiles together. And for example, for the point 1, Fs is 0.478 for the left wheel, and for the right wheel it's 0.263. With that, for the dual tile, there will be 0.741. That will be the summation of these two deflection factors. This will be applied for all the other 2 points for the single tile, single wheel, and the dual wheel. And then you will find that for the calculation, you need to find out the maximum value of these two columns. For the left column, for the single wheel, the value is 0.478. For the dual wheel, I guess I typed something wrong here. I'm trying to modify it when I introduce this one. So let me see what I can do any modification. Just a moment, let me try to save this one and do the modification. Okay, okay. So the FD, the deflection angle of the right lane of the dual wheel should be 780, which will also be the maximum value of the last column. And with that, you can recall the formula defined by Fosteralvins, and you have PS equal to FD divided by FS times PD. And we know that FD is 0.780, and FS is 0.478, which will be maximum value of this column, and the PD is 4500, and then you can calculate the ESWL, which will give you the value as 7,340 pounds. And this one is pretty close to the one that we estimated in the previous example, in the first example with the linear relationship. But this is actually just in the real case. Usually with the Fosteralvins method, the value, the ESWL that is estimated, will be much higher than the one from the linear relationship. You will find out the difference in some homework assignment, and maybe in or some other examples in this class. Okay, so I guess that's all about the lecture today. I'm sorry that I don't have my pen is not working for now. I need to recharge this one. So there are something left. There are several pages left for about the other criterions, and I will go through them quickly in the next lecture. With that, I will leave several minutes for the questions. If you have any questions about the midterms, the homework questions, or if you have any questions about lecture today, you can raise your hand or leave the message in the meeting chat. Do you have any questions for now? If you have any specific questions about the format of the midterm, so I will recommend you go back to watch the video in the last lecture. We have some descriptions about what kind of format it's going to be, how many questions you will have in the midterm exam. For the midterm, it's scheduled on this Wednesday, from 2:30 to 4:30, and you have 2 hours to work on all the questions, and also you need to think about saving some time to upload your answer sheet. All those questions will be a simple question. It does not involve with a heavy computation. So if you go through something complicated, it probably means that you are doing something wrong or you're using the wrong method to solve the question. So I would recommend you to go through all the examples and the homework assignment. This will be very helpful for you to prepare for the midterm exam. All the questions in the midterm exam will be similar to the homework problems, and therefore for the questions, the fundamental knowledge questions, you can find out the answer, the exact answer from the course notes. So you must be very familiar about the lectures, and also try to go through all the examples and the homework solutions. Okay, if you don't have any questions, I think I will stop the lecture today, and just feel free to send me email if you have any additional questions. And the TA will also be available will be available to reply your questions. Just to think about the tutorial session, but tutorial session is set for the midterm. So just send me email or email the TAs for any questions, and we will try to reply you as early as possible. Okay, I think that'll be all for the lecture today. Thank you very much for your time. Mohammed, do you have any questions?
How are you? Just a quick question. I know you explained it in the midterm review session yesterday. Just wanted to make sure for the lecture notes, is it up to which lecture note?
It's up to all the materials to the last week. So if we go to check the note number, let me go to check the avenue to learn. All the notes except this one. All the notes except this note.
Okay. All the notes. So everything up to note, like everything including note 16 and the midterm review.
Yes. Yes.
Okay. Thank you so much.
Okay. Okay. Any other questions? Okay. If no, then that'll be all today. Thank you very much, and I will see you on Wednesday for the midterm. Oh, by the way, I'm going to create a meeting under the midterm channel. And if you have any questions, just bring the questions in the meeting channel during the exam. Okay. Good. Okay. Thank you very much. I will see you on Wednesday.